T-tests are basic and fundamental to traditional inferential statistics. They are widely used and incorporated into much more complicated statistical techniques. Therefore, having a basic understanding of t-tests can go a long way in understanding more complicated statistics. Let's get into it. There are basically three main types of t-tests. The first is called a one-sample t-test. I'll use this when I want to compare some group to some known or hypothesized average. Let's put that in plain language. One-sample t-tests are kind of like a weirdness test. If I collect data from a group of people, I can compare them to what I should expect to see. If they are different than what I expect to see, well, they're a little weird, aren't they? So here's an example. I could measure the height of centers who play college basketball in the United States. I could then compare them to the average height of men in the US, which is usually about 5'9". What we're basically testing here is, are college basketball centers weirdly tall? Probably, right? To be clear, what we're doing here is we're collecting data from a sample, and we're comparing that to some mean value. That could be a population mean that was estimated in a previous study. It could be an entirely made-up number, an entirely hypothetical one. It's just a comparator. The hypothetical or comparator value should probably come from some theory or known estimate of what a population mean might be, but it doesn't necessarily have to. The math still works. The next type of t-test is called a dependent samples or a paired samples t-test. Either term can be used. Keep in mind that even in this scenario, you are still just looking at one group. There's still just one group of people that we're collecting data from. To understand how this one works, I want you to imagine that you are one of the participants in the study. Here you are. Imagine I'm a food researcher, and I'm doing some research on how much the flavor of foods or the quality of foods change how much people say they like those foods. When you first come into my study, I'm going to ask you how much you like asparagus on a scale of 1 to 10. Maybe you say 3. You're not a big asparagus fan. Now I have a talented chef prepare you some asparagus, seasoned deliciously. This is a critical point. I then am going to ask you to come back and rate how much you like asparagus again. It's important that I'm asking you to come back. That's what makes this a dependent test. I ask you for your preferences, then I do something to you like make you eat asparagus, then I ask you again. That's an important pattern. Your answer depends on your previous answer, because it depends on your general preferences to begin with. How much do you like asparagus after you try the chef's recipe? Well, that depends on how much you liked it before. You said 3 before. The chef's recipe was delicious, so maybe you say 5 afterward. It changed your opinion, sure, but you still don't like asparagus all that much. Helga, who is also in the study, says that she likes asparagus 10 out of 10. It's not even possible for her to like asparagus more. No matter how much she likes the chef's recipe, she still likes asparagus 10 out of 10. The chef didn't change her opinion. Dependent t-tests are about changes over time. For instance, changed preferences after an intervention. The final type of t-test is a two-samples t-test. This is one of the most common and one of the easiest to understand. In a two-samples t-test, or an independent samples t-test as it's sometimes called, you're just comparing two groups to one another. With all of the different t-tests, you're looking at mean differences. Basically, is one mean significantly different than another one? In the one-samples t-test, you're basically just comparing your group's mean, your group's average, to some population estimate, or some other hypothetical mean, or some other value that you've decided to compare it to. In the dependent samples t-test, you're checking whether a group's mean changed after some time, usually after an intervention, like the chef's asparagus. In the independent samples t-test, you're just looking at whether one group's mean is different than the other group's mean. Importantly, you're not going to wait in this case. You're going to measure them right now. Are they different right now from one another? Importantly, if you end up in a situation where you're comparing 3 or more groups, use a one-way ANOVA. Do not do a whole bunch of t-tests. Doing multiple t-tests actually leads to an issue called alpha inflation. Please don't alpha inflate. It's bad. If you absolutely must run multiple t-tests, you should correct for multiple comparisons using something like a Bonferroni correction or a Benjamini-Hochberg correction. Links to online calculators in the description. T-tests are actually widely used in many fields of research. They're also used in more complicated statistics such as regression and structural equation modeling. Since they are so basic and foundational, hopefully this lesson provides some foundation for learning more about traditional inferential statistics.